Welcome to the DIVA website, developed by David Deacon and James Stanier of the Centre for Research in Communication and Culture at Loughborough University, in conjunction with Business Intelligence and Strategy Limited. This short video explains how to use DIVA to measure diversity from categorical data. When we talk of categorical data, we are referring to the use of numbers to locate different cases into separate categories. For example, categorising respondents to a survey according to their ethnicity, party political orientation, or level of educational attainment. Categorical data are sometimes also referred to as nominal data or qualitative variation. When you enter a data distribution into DIVA, 7 diversity measures will automatically be calculated. Measures 2 to 7 are diversity indices that have been developed across a range of disciplines. The first measure, DIVA, is a new measure we have developed and is calculated by averaging measures 2, 3, 4 and 5. Our research shows that this combined measure has significant advantages, which we discuss further in the publication we have produced in conjunction with this website. Measures 1 to 6 all produce standardised diversity scores that range from 0 to 1. A score of 0 indicates there is no diversity in a distribution, whereas a score of 1 indicates there is an equitable dispersion of values across all categories. The one exception to this scoring is the Herfindahl-Hirschman Index, HHI, which generates a number between 0 and 10,000. For this measure, the lower a score is, the greater the diversity in a distribution. To operate DIVA, open the website and click on the grey button. You are then presented with 2 options on the next screen. You can either measure the diversity of a single distribution, or you can compare diversity scores for 2 distributions. DIVA automatically calculates 95% confidence intervals for each diversity score. This is an estimation of where an actual population value is likely to be located on the basis of sampled data. More information is provided on this website as to how these estimates are calculated. When you select the first option, you enter the data input screen. This is where you enter the values in your distribution. You have the option of adding a title to your data group. You then enter your numbers. You can leave a space between values or separate them with a comma. These values can be either observed frequencies or percentages. If you are entering percentages, do not include decimal points. Either round the percentage or express the percentage as a full number. For example, 78.1% should be entered as 781 and 10% as 100. Here is an example of a categorical data distribution derived from election research conducted at Loughborough University. During the 2015 UK general election, we analysed a sample of TV and press coverage of the campaign. As part of that analysis, we identified how frequently political representatives from each political party were directly quoted in coverage. We identified this distribution of party appearances across the entire sample. Returning to the data entry screen, we now enter the values. Once again, you can place a comma between each value or simply leave a space. Do not use full stops. You then click OK. This will take you to the results screen. The data you've entered are listed at the top. Below these figures are the results for each of the 7 diversity measures. Below each of these scores is the 95% confidence interval information. For this example, for the diversity average figure, we calculate on the basis of the observed distribution of 0.809, there is a 95% probability that the population diversity figure sits somewhere between 0.728 and 0.861. The results page can be printed out or saved as a PDF. To compare the diversity scores and confidence intervals between 2 variables, you select the right-hand tab on the entry screen. This option allows you to calculate the probability that any observed differences between 2 diversity scores occurred by chance. To demonstrate how this works, we compare the data distribution we've already entered with an identical analysis of national media coverage of the 2016 UK referendum on whether Britain should remain part of the European Union. If we compare these distributions, it is clear that the Conservative Party gained a significant higher proportion of quoted coverage in the referendum compared to the 2015 general election. The question is, can we deem this difference to be statistically significant? When you select the right-hand button, this data entry screen appears. We can now enter the distributions for the two variables we want to compare. In this case, the differences in the general election coverage of 2015 with the referendum coverage of 2016. You then click OK. This takes you to another results screen, which once again can be printed off or saved as a PDF. At the top of the page, you see the variables and values you've entered for the comparison. Below this, you see the diversity scores and the confidence intervals for each of the measures for the first set of data, in this case the 2015 general election. Below this information you see the same results for variable B. At the bottom of the page, the first line compares the absolute difference between the two diversity scores for each measure. For example, in this case the absolute difference between the DIVA scores for political diversity in the 2015 UK general election and the 2016 EU referendum is 0.266. We then need to consider the probability that this difference has occurred by chance. Could it just be a product of the random variation one might expect when sampling? In this case, the p-value for DIVA is 0.0391, which means we calculate there's less than a 4 in 100 or 1 in 25 probability that this observed difference occurred by chance. This is below the most common criterion applied to judge statistical significance, 0.05, and therefore we're able to conclude there is a statistically significant difference in the political diversity of national media coverage of the 2015 UK general election and the 2016 EU referendum. The procedures used to calculate these probability scores are explained in the publication that has been developed in conjunction with this article. Thank you for viewing this video.